Hello all, welcome to the series of data structures using Java. Here the discussion is about linked list. In this video, we'll see what is a linked list, how a node is represented in the list, what are all the different types of linked list in data structures. Along with that, we'll also see the basic programming in Java for the list. Let's get started with the linked list. What is a linked list? A linked list is a linear data structure. And what is mean by linear? So linear means the data are arranged in a sequential manner. That is, you cannot access a data value randomly. If you want to access any data, then you should start from the first node and move to the next node in a sequence. Likewise, you will reach the node value that you want to search for or that you want to access. Linked list is an example for linear data structure. In linked list, all the elements are not stored in contiguous memory location. That is, for example, if you take an array. So here we have an array which consists of number of elements in it, and all these elements are stored in a continuous memory location. For example, if this is my first memory location for the first value, index 0, then the next value will be immediately 1004 if my data that is inside this array is integer type of data. Okay, in Java, if you take integer type of data, the size of integer is 4. Okay, 4 bytes. So here same way, if I store integer type of data in the array, right, so each element takes 4 bytes of memory location. In that case, if you see here, the first element would be stored at the memory location 1000, whereas the second element will be stored in the position 1004, and third element would be stored in the position 1006, whereas the fourth, sorry, 1008, and then the fourth element would be at 1012. So this is how elements in array get stored, like the memory location you can see, which is continuous. But coming to linked list, okay, when we take linked list, we have list here. Okay, we contains list, that is nodes, which is in the form of list, and these nodes will be stored in a non-contiguous memory location, like not like this, like 1004. It is not like this. So this will be at memory location 1000, but this node can be at memory location 5000. Okay, likewise the other node can be at memory location 10,000. So in that way, all the nodes of the list will be stored randomly in some memory location. That is what called here elements are stored at non-contiguous memory location. And then coming to linked list, yes, it consists of nodes, and if you take a node, that node contains data as well as a reference. We can also say it as a link. Okay, so what is that reference or link here means? Which is referring to the next node in the list. Okay. That is what a node basically contains. And coming to linked list, so the advantage of linked list is it is allowing a dynamic memory allocation. If we take array is a static memory allocation where you cannot able to expand the size of the array or shrink the size of the array during the execution time, in between execution. But coming to linked list, it is not the case. So if you want to expand the size of the list, you can able to do it, or if you want to delete some nodes in the linked list, and if you want to shrink, yes, you can do that. Okay, it is allowed in linked list. So that is why it is called as dynamic memory allocation. Then coming to structure of a node in linked list. So as already mentioned, a node consists of data and a reference, and here reference is given as link. Okay, so this basically stores the data value. Okay, and coming to this field stores the address or pointer of the next node in the list, right? Because I told you in linked list, nodes are not stored in a contiguous memory location. The memory location can be random. So how do you connect all the nodes? By using this reference only. Okay, you're going to use this reference to connect the nodes, right? And types of linked list. So here I listed some of the types, like single linked list, doubly linked list, circular linked list, and circular doubly linked list. Okay, so we'll discuss about singly linked list in this video. And this is the structure of singly linked list, where you can see it consists of nodes connected with each other. And if you see here, the node contains two parts. One is data part, which is actually storing the data value, and the second part is a link, okay, where it will store the address or memory location of the next node. And here the next node memory location is A, so this address field contains the value A. In the same way, if you look at here, this memory location is B, and this node is linked with this node, so it contains the reference B, okay, memory location B. In the same way, the next node has the reference of the next node, that is E. And at last, the last node always contains null reference pointer, okay, because this is the end of the list. After this, you don't have any nodes to be connected. So always the last node should be end with the null reference pointer. And always the first node is taken as the head node, okay. We'll be referring the first node as the head node, and you can call the last node as the tail as well, right? You can call this as tail. Now, operations of single linked list. What are all the operations we can perform in single linked list? So these are all the basic operations, like we can perform search operation, insert operation, or delete operation. Then we can find the length of the linked list, okay, because this is dynamic. We do not know what is the length of the linked list, what is the size of the list here. So we can able to find the length of the linked list, and then we can check whether our linked list is empty or not. Then after that, we can perform traversal, which means you can able to visit each and every node of the linked list. And then creation of node in single linked list. So basically, whenever you are performing any insert operation, first you need to create a node for performing insertion. So how do we create a node for the insertion process? That we will discuss now. So first is creation of a node, okay, and we know the structure of the nodes. Node contains two parts. In singly linked list, a node contains two parts: data part and next part. Here the data part can able to store a homogeneous type of data. That is, we can say it can be integer data or it can be a character data, right? And the next is always holding the address of the next node. So how do we create a node? What is the structure we use to create a node? Okay, so for creating a node in Java, we use class. Okay, with the help of class, you are going to create a node. Class followed by the name of the class. Here the name of the class is node. And within the class, you can see I have declared two variables. The first variable is data, which is of type integer. Okay, which means my first field will be holding the value that is integer type of value. And the variable name I have given for this is data, right? And what will be my next field? Next field is pointer field. So here in this pointer field, you are going to store the address of another node. Okay, so for that purpose, you are creating the next field, right? And the variable name I have used here is next. This is the next field, and the type of the next field is node, because you are going to store the address of another node. Okay, that is why I have given here node. The data type is node, right? And coming to this part, what is this part? This is actually a constructor. Okay, see, if we are coming for this implementation, first you should know the basics, fundamentals of Java, right? And if you look at Java, here we have a constructor for this class, okay? And this is parameterized constructor. You can call it as a parameterized constructor. Always the constructor has the name same as the class name. You can see the class name is also node, and my constructor name is also node. So always constructor has the same name as your class name, and this is called parameterized constructor because you can see there is a parameter inside this constructor. Okay, so here you are going to pass some value. When you are calling this constructor, you are going to pass some value, and that value you are going to use here inside this constructor. Okay, and what is the value we are passing here? This value is nothing but the data value of a node that you are going to create. If I want to create a node with the data value 1, I can simply pass 1 for this D. Okay, if I want to create a node with the data value 5, then what I can do? I can pass 5 value here, right? So this is nothing but the value, okay, but the value which you are going to store in a node, that is what passed here. And here we know that the first field, that is data field, for the that is given by the variable data, and this field contains the data value. So you are assigning this value D value to this data field. And what about the next field? When a new node is created, always assign the next field as null. Okay, so whenever I'm creating a new node, you assign the data value. Along with the data value, you also assign the next value as null, right? So this is how you're going to create a new node. This is the code for creating a new node in Java. How do I call this? Okay, I have created a node, right? Like I have not created yet. Actually, I was about to create, but this is the code for creating a node. How do I create? Once I call this constructor, then a new node will be created. So this is the way I can create a node. If you see here, always your execution starts from the main function. And inside main function, I have created a new node. Okay, an object. Actually, I have created an object for the class node. So what is a class? This class is a node class, and for this I have created an object. This is my object reference. Okay, so this is my object reference and I have created an object with the keyword called new. So this new keyword will create a new object for this class node. Okay, and the object reference is new node, right? You can see here I'm using the constructor with some value. Okay, I'm calling the constructor by passing some parameter. Okay, and this parameter will be passed here. When I pass value 10 here, so here D will be containing value 10 and a new node will be created with the value 10 and the next field as null. So this is how creation of node works. Then coming to the next operation, traversal. So traversal means you need to visit each and every node in a linked list. Okay, so for example, this is the list, okay, which contains 1, 2, 3 and 4 data. Okay, and if I want to traverse this, I need to start from the head node, then I have to visit the second node, then I should go to third node, then at last I should go to fourth node. So how do I traverse this? Okay, how do I traverse these nodes in the linked list? So that is the code given here. If you see here, first I have created a node, okay, that is called as temp. So I'm creating a temporary node here, okay, node temp equal to, and I'm assigning the temp node as head. So here what is the head node? The head node which always points to the first node of the list. So here this head node is assigned to temp, which means now this node, first node, is also called as temp node. Okay, so I assign head node as temp. Now what you need to do, from this node you have to move to the next node. How do you move to next node? So we already know that these two nodes are connected with a reference. Okay, so through this reference only you are going to visit the next node. Through this link only you are going to visit the next node. And what is the link of this node? A. So if you have A here, so this will search for the memory location A, because I told you it is not contiguous, it is non-contiguous. Memory location is non-contiguous. So this will search for that particular memory location and it will fetch the data from that memory location. Okay, that is how this list works. Actually traversal works. So if you want to traverse from this node to this node, that can happen only through this link. So what is the name of this link we have given in our program while creating? So next, so this is my temp node. The first field of the temp node can be referred as data field and this field of this temp node can be referred as next field. So how can I access this temp node data? Temp.data. How can I access this next value of temp node? Temp.next. Okay, so this is my temp node. Temp.data means it refers here, temp.next means it refers here, right? So if I know my temp.next, then I can move to my next node and now this node will become my temp node. Okay, now this is a temp node. Again, if I want to move to the next node, traverse to the next node, what I have to know? I should know the temp.next. So this is my temp.next now. Again, if you found M, so you are moving to M and you are making this node as temp node. Now again you want to traverse to the next node. So for that what you need? You need temp.next. Okay, so you found what is temp.next? K. So where is K? K here. So you are traversing here. Likewise, you are going to traverse all the nodes of a linked list until your temp.next becomes what? Null, because null always indicates the end of the list. That is the last node. After that you don't have any node, so you don't want to traverse, right? So you are going to stop this process when you reaches the null. When what reaches null? When temp reaches null. Until your temp becomes null, you are going to do the same process. Okay, you are going to do this process iteratively. So that is what given in the form of code here. You can see for the iteration I have used while loop because I do not know what is the length of my linked list. So where to stop the linked list, I do not know exact point. So for that reason I have used while loop, and inside this while loop you can see until my temp becomes null. Okay, so once this like this condition becomes true, okay, this loop will get executed. If the condition becomes false, then this block will not get executed. This is how while loop works. So here first this is my temp node. Initially this is my temp node. You are checking whether your temp is not equal to null. Yes, my temp is not equal to null because this is my temp node. It is not null. If it is not null, then what you are doing? You are moving to the next node. So for moving to the next node, what you are doing? You are assigning temp equal to temp.next. Okay, so what is temp.next? This is temp.next. You are assigning temp.next as your temp node. So now this will become your temp node. Okay, again it goes to this while loop and checks for the condition whether your temp is equal to null. Temp is not equal to null. The condition is true. If it is true, it will execute the statement. So this will continue until your temp becomes null. So when it reaches here, if your temp reaches here, then this will stop calling this block again. Okay, because that time this condition will become false. So this will stop the iteration. This is how you are going to traverse the linked list. The next operation is finding the length of the linked list. So finding length is very easy, because if you understand the traversal, then it is very easy to find the length of the linked list. Here also, if you want to find how many number of nodes in your linked list, what you need to do? You need to traverse this list starting from the head node to the tail, that is last node, right? So when you are traversing, you can able to count. If your temp is here, you can count this as 1. If your temp moves here, you can count it as 2. If your temp moves here, you can count it as 3. If your temp moves here, you can count it as 4. So in this way, okay, while traversal, what you can do, you can able to count the number of nodes in the list. So that is what you are doing here. If you look at this code, same way, I have created a temporary node, okay, and I'm assigning head node as the temporary node. Here I have used one more variable, that is called count. Initially I'm like assigning the value as 0 for this count. I'm initializing this count as 0 because now I didn't start my iteration. So once after I start my iteration, if I find any node that is existing in the list, then I'm going to increment my count. Okay, so initially there is a temp node. So in that case, if this condition is true, temp is not equal to null, then it executes this loop. And in this place, my count value gets incremented to 1. After incrementing the value, then I'm moving my temp from first node to second node. That is why this assignment is given. Okay, so now your temp node is second node, not the first node. Okay, after this statement, your temp node will be pointing to the second node in the list. Again, it comes to this while loop. It checks for the condition temp is not equal to null. Then again it executes this count plus plus. Now my count value again gets incremented to 2. Okay, then the next statement, again you are moving your temp value to the next node value. So this is how you are going to traverse. While traversing, you are also counting how many number of nodes you have actually traversed. Okay, that is what the actual thing happening here. You are counting how many number of nodes you have traversed. So based on that, you found the number of nodes, that is length of the linked list. And the next operation is finding whether a list is empty. Okay, so in order to find whether a list is empty, a simple code you need to check, because whenever your list is empty, always head will be pointing to null. That is what we will assign in the starting itself. Okay, we'll assign head as null in the starting in order to indicate that your list is empty. Okay, so here when the head is pointing to null, then you can say your list is empty. So the same condition you are going to check here. If your head node is equal to null, okay, then you are going to return true. Why am I returning true here? Because what is the data type I have used here? I have used Boolean data type. Boolean means either true or false. Okay, so if I used void, I will not return this true or false, but here I have used the Boolean data type. If I'm using Boolean data type, that is return type for my method, this is called as return type. So if I'm using this return type for my method, then you should return either true or false. So here you are going to check is empty, that is if your list is empty. So when your list will be empty, if head is equal to null, yes, you have to return true, yes, your list is empty. Otherwise you have to return false, indicating that your list is not empty. Okay, this is how you need to find whether the list is empty or not. And the next operation is search operation. So how do you perform search? Basically with the data value. So you are given with a data value. For example, in this list, I need to find whether 2 is present in my linked list or not. I want to search for the node having value 2. So how do I search? First, I will start my search with this head node. I will check whether the data value is 2. If it is not 2, then I will move to the next node. Again, I will check the data value of this node. If it is 2, then I will stop my process here and I will return the position, or I will return the node is found, whatever. Right? If again, here instead of 2 you have some other value, you don't have 2 here. Okay, again what you will do, you will move to the next node and you will compare the data value with this node value, whether it is 2 or not. Okay, so in this way you will be searching for a value in the list. For this also, if you see clearly, you need to apply traversal. Okay, because first you need to Take the head node, compare the value with the data value. If it is not equal, then traverse to the next node. Again, if it is not equal, traverse to the next node. So until your node becomes null, okay, until it reaches the last, then you need to, you need to repeat the process iteratively. Meanwhile, you are not only iterating here, you are also comparing the data value every time in the every node, right? So that is also included. So you need to write a code for that. How do we write a code? As usual, here you are taking a temporary node and you are assigning head node as temp node. Now this is my temp node, right? So in this temp node, you have to start from this node. So for traversal, I'm taking the same while loop, while temp up until like my temp becomes null, I'm going to do this process. So the condition is temp not equal to null. You are checking temp not equal to null. Yes, temp is not equal to null. Then execute this block. And inside the block, you are checking the condition. What condition you are checking? I need to check whether my data, temp.data is equal to the data which I passed here. Okay, the node which I'm searching for, the value which I'm searching for. So you're comparing that in this if condition. Your temp dot data is equal to data. Yes, if it is true, if it is matching, then you're returning true. Why am I returning true here? Again, what is my return type? My return type is boolean, which means I should either return true or false. So if the data is found, then I have to return true. If the data I'm searching for is not found, then at that time I will return false. Okay, so once you found the data, you will return true. Suppose if the data is not present here in the first place, what you will do? You will again traverse to the next node. How do you traverse to the next node? By assigning temp is equal to temp dot next, by referring the next of your temp. Okay, that is what happening here. Temp is equal to temp dot next. So which means temp dot next, you are referring, this is your temp dot next. You are assigning this temp dot next as temp. Now this is my temp. This node becomes my temp. Again, it enters into this while condition. It becomes true. Again, it will check whether the temp dot data is equal to data. So what is temp dot data now? It is 2. And what is my data? It is 2. It is equal. If it is equal, then what it will do? It will return true. After that, it won't execute these statements because this is a return statement. So this will return, right? So this is how you need to do your searching. Okay, this is the code for search operation in Java. We'll continue the insertion operation in the next video.